So when you have two parallel lines that are cut by a transversal, they make two pairs of vertical angles. So if we look here, let me get just a pen. So if we look at these four angles, by the fact that they're vertical angles, meaning across two lines that are intersecting, I know that angle 2 and angle 4 will be the same measurement, and I know that angle 1 and angle 3 will be the same measurement because that's the definition of vertical angles. But now, when we have another line which is parallel, cut by that same transversal, you get four more angles, and it turns out that those four angles are actually related to the original four angles. Again, they are two pairs of vertical angles, but their measures will actually match 1, 2, 3, and 4. Because the second line is parallel, so the transversal intersects at the same angle. So what that tells me is that 5 and 7 match, and I'm coloring them green because they really for real match angle 1 and 3, and similarly 6 and 8 will be the same measure, and it will be the same measure as 2 and 4. Now the only other thing that you need to know is that if you take orange and you add to it a green angle, then that should equal 180 degrees. Because again, if you look at a green and an orange, or we could do it this way too. If you have a green and an orange angle, they make up a line. So a line has 180 degrees. So when you add the two angles, it will add up to 180 degrees. So in this problem, they tell you that the measure of angle 5 is 38 degrees. So this guy here is 38 degrees. But that means that every single green angle is also 38 degrees. So this guy is 38 degrees. This guy is 38 degrees, and this guy is 38 degrees. Now, how would we find the measure of the other angle? So we found all the greens, and in our problem, all the greens were 38 degrees. Well, I know that if I add to orange 38, it should make 180. So if we just subtract, we get orange equals 142. So the orange angles, every single orange angle will have a measure of 142 degrees. So angle 4, angle 2, angle 6, and angle 8. So then from there, once you can label all your angles, then you can answer the question that it gives you. So now in this next example here, you've got a ramp which is 16 feet long, and it rises to a platform that's 14 feet off the ground, and we want to find the angle of elevation of the ramp. So the angle of elevation is going to be the angle that the ramp meets with the ground. So now this angle here is what we're looking at, right? So what do I know about the triangle that angle is inside? Well, I know that in that triangle, I'm going to just draw it without all the words here. Here's my angle X. And this is a right triangle, which is really important because in a right triangle, you have a hypotenuse. So your hypotenuse is length 16. And then the tallness of the building or the platform is 14 feet. This is my platform side. So now, in regards to X, right, the thing I don't know, 14 is opposite of X. And then 16 is the hypotenuse because it's across from the right angle. So which trig function uses opposite and hypotenuse? So remember, trig is SOHCAHTOA, which tells me sine is opposite over adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're going to look and decide, what do we have? We've got the opposite and the hypotenuse. So that means that we know the sine of that angle, whatever that angle is equal to 14 over 16. So now we have to figure out what angle x is. And if you look, it says to round your answer to the nearest tenth of a degree. So x is going to equal the sine inverse of 14 over 16. In some places they write sine with a little -1 up top for sine inverse, or in some places they write arc sine. Either way, that is how we're going to find our answer, but you need a calculator for this, so there's no way to get out of that. So let me see, I got my calculator here. I want to do, let's see, I'm in degrees, you can't see that, but on your top left, it's like right off the screen, I see DEG. So now I'm going to, let's see, trigonometry, second. I want sine inverse. Okay, so first in this calculator, I have to do 14 over 16. And that's whatever decimal. And then I'm going to hit the sine inverse button. Not hyperbolic, sine inverse. And I got 61. Again, it's just slightly off your screen. Let me see if I can get it on there. 61.0449. So x is equal to 61.0449 degrees. And then the directions say to round to the nearest tenth of a degree. So tenth is 1 decimal. So you're going to look to the right and see. It's either going to be 61.1 or 61.0. So you look to the right of the 0, and that digit tells you whether to bump up or keep the same. So here it's a 4, and 0 to 4 we keep the same. So my estimated answer would be 61.0 degrees. And again, you need to do that in a calculator. You cannot do it in your head. And then the last question you had was about a this word problem. So a swim race has a total of 25 miles. Race officials want to mark the course every 500 yards with a buoy, including one at the finish line. The starting line does not need a buoy. How many buoys are needed? Okay, so first of all, I'm going to just take these guys out. There's no way for me to copy it without that. Okay, so we're going to decide we want to get from miles to buoys. So now we're starting with miles, and we know a buoy is going to happen every yard. So we need to convert our miles to yards. So we're going to go first from miles to yards. Well, let's see. In order to get yards, we need feet. So these are my 2 miles to feet ratio. And I need to cancel miles out. So I have miles on top here. So I'm going to pick the ratio that has minus or miles on bottom. So that's this guy. So I would just drag that in as 5,280 feet for 1 mile. Okay, so now miles has canceled out and I'm at feet. So we went from miles to feet, and now we have to go from feet to yards. So again, these are the two, 3 feet and 1 yard. These are the two ratios that I have. And I want to cancel out feet. So here I've got feet on top. So I want to use the ratio that has feet on bottom. So the feet unit will cancel out. So the next place that I'm going to go, and the next ratio I'm using is 1 yard over 3 feet. And I think you can just drag and drop it. 1 yard over 3 feet. So now the feet on top cancel with feet on bottom. And now I'm at yards. Okay, where do we want to go from there? We need to get from yards to buoys. So here are my two ratios, which represent buoys and yards. So now yards is on the top here, and I want to cancel it out so I have buoys left over. So I need to use one of those that has yards on bottom. So this second one has yards on bottom, so I'm going to put 1 buoy for every 500 yards. So now to do this math, we would multiply straight across. So we're going to do 25 times 5,280 times 1 times 1. And then on bottom, we'll do 1 times 1 times 3 times 500. So let's do that math in a calculator. 25 times 5280 makes 132,000. So here I have 132,000. And then my bottom number, this is ultimately a fraction. My bottom number will be 1 times 1 times 3 times 500, which is 1,500. So now let's simplify that. We'll do 132,000 divided by 1,500. Oops. So wrong button, sorry about that. So 132,000 divided by 1,500 equals 88. So we need 88 buoys.